students. Here is your first video from our session, and I'm going to be going through the first page of the summer packet and highlighting some things for you to think about, as well as trying to give you a little foreshadowing about where each one of these topics is going to be used in the upcoming year. So our first page and first problems were these three simplification problems. So the first thing I want you to focus on is this word simplify. When you are asked to simplify, you are not being asked to solve anything. In other words, your answer is never going to be x equals 2 or x equals whatever, right? You are only simplifying, which means simplifying is the same thing as rewriting, right? So you just need another format, and sometimes and sometimes your simplification is, the purpose of it is to be able to make the next steps in your math easier, but sometimes it is specifically for AP exams on the multiple choice part, your answer that you get isn't one of the answers, but an alternate version is. And since you only have about 2 minutes per question, you want to be able to recognize, hey, my answer isn't wrong, it's just the same as choice C. So you don't have to go back and try to find a mistake. You're like, oh no, it's just the other version. Now, these three particular problems, though, are going to be used in our limit unit, which is the second unit that we start after reviewing. So really the first unit of calculus. In order to evaluate something called limits, and maybe you studied limits in pre-cal or maybe you didn't, it doesn't matter. When we teach, whether in A, B, or BC, when we teach you limits, we teach it as if you haven't seen it before. So if you've seen it before, great, it's back there in your, just have to dust off the cobwebs. But if you haven't, it's okay. So each one of these problems, A, B, and C, was specifically chosen because the very first things we do with limits involve figuring out not just to simplify these fractions, but to be able to find a common factor and cancel it out. So before I do that, though, I just want to do a little bit of recall back to middle school, right? Or even elementary school. I can tell you that you do know, right? There's some things about fractions that you already know. Here's a fraction. What if I gave you a fraction like 10 over 15? There's nothing wrong with 10 over 15. It's a perfectly nice fraction. But in reality, you are factoring the numerator if somebody asks you to simplify, and you are factoring the denominator. And then you're saying, since this is multiplication, wait a second, 5 over 5 is equal to 1, and 1 times 2/3 is the same as 2/3. And that is why 2/3 and 10 over 15 are the same ratio. Right? It all comes from the identity, the multiplicative identity of 1. Notice this does not work if I had 5 plus 2 over 5 plus 3. You cannot say that this fraction is equal to 2/3 because you canceled out the 5's, right? This fraction is actually 7 over 10, which is not equal to 2/3. So I can't tell you how often this happens to very smart and reasonable math students who just in a hurry, forget that you need multiplication or factors to be able to use the multiplicative identity property of multiplying by 1, right? Not here. So the difference between having terms, and again, most students would never do this, but the minute somebody puts an x in there, somebody says, oh, I've got x plus 2. Over x plus 5. Sorry, x plus 3. Right? Students who wouldn't cancel these 5s, go ahead and cancel the x's. Oh, please stop it. Right? That is actually something you do know from elementary school. Right? Those two fractions are not equal because 5 plus 7 is different than 5 times 2. Okay? So keeping that in mind, I want to do the same process with this fraction up here. I want to take the numerator and I want to factor it. Well, there is nothing to factor about x minus 4. There's nothing to do. But when I have a quadratic, x squared, a quadratic is going to have 2 factors. Now maybe those factors aren't nice, right? Maybe they're not even real numbers. But given that I've asked you to simplify and x minus 4 is in the numerator, I'm going to guess that x minus 4 is in the denominator. Now, can you factor this quadratic? This is something you've been doing since Algebra 1. I have a leading coefficient of 1, and I have a constant that equals 4. Now, here's something else from middle school before I finish this problem. From even, again, elementary school. When someone says to factor 10, if I said to factor 10, and I gave you the factors 5 and 3, what would you say to me? You're wrong, right? When you tell me that's not true. How do you know it's not true? Because when you multiply 5 and 3 together, you get 15, which does not equal 10. But if I ask you to factor 10, and you tell me 5 times 2, right? So this is wrong. This is right, because when I multiply 5 times 2, I get 10, which is equal to the original expression. Again, students forget about this when this simple check when they get to algebra, where the x's just hold places for the numbers. So again, when I'm looking at this and I want to say, oh, x minus 4 over this quadratic factors, and let's say I think it's x minus 2 over x minus 2. Well, am I right? Are the factors of x squared minus 3x minus 4 x minus 2 times x minus 2? I don't know. But you know what I can do? I can check. X minus 2 times x minus 2 is x squared minus 2x minus 2x plus 4. No. Nope. So these must not be the factors. It's as simple as that. It don't work because it don't work. Again, since I'm simplifying, I am going to guess that this is x minus 4, and hopefully you can see that this is got to be x plus 1. If you're not sure, multiply these out. Right? X times x is x squared. There's a positive 1x, a negative 4x. Combine that, it's negative 3x. Multiply, and that's negative 4. For some of you, you're like, duh, I just could speed right through this, right? Because I've practiced factoring quadratics and I'm pretty good at it. For some of you, you're like, well, that's not a big deal, right? It just means you haven't practiced enough and you've now identified something, a skill that you need going forward to be able to access AP Calculus, whether it's A, B, or BC. You need to be able to factor quadratics quickly and easily. So if that right there has thrown you, you're not sure what's going on, you need to write in your little notes in your list, A skill I need to practice is factoring quadratics. All right. Meanwhile, let me go ahead and write this again. And hopefully you can recognize that I have matching factors. It's the x minus 4 is in a room. This is the same as, right, 5 divided by 5 is 1, because I am multiplying here, and technically there's a multiplication by 1 there. So this answers 1 over x plus 1 is a different way to say x minus 4 over x squared minus 3x minus 4. Those two expressions are the same. Sometimes this expression is just fine, but there are other times that I need this expression. And one of those times that you're going to need that is when we do limits. Now, before I move on, I have something else to say about this. This is the original problem. Right? This is your original problem. This is what you were stuck with. This one originally had 2 factors in the denominator. So here's what I want you to do. I'm going to take the original and I'm going to plug in 1 for x. So if I plug in 1 for x, I get 1 minus 4 over 1 squared minus 3 times 1 minus 4. What do I get? Negative 3 over 1 minus 3 minus 4. What is 1 minus 3? Negative 2. Negative 2 minus 4 is negative 6. So this is negative 3 over negative 6. But doesn't that reduce to positive 1/2, right? Now, plug in 1 for x into the simplified version. I get 1 over 1 plus 1, which is 1/2. Notice that I got to 1/2 faster than I did here, but I still got to 1/2 using the original. So the simplified version does help me with speed sometimes, right? But I had to go through the process of simplifying first. So if it doesn't matter, if speed isn't really of an issue, or you take too long simplifying, well, maybe I don't want to simplify. But the point is that you get 1/2 no matter what. Except, what if I asked you, instead of asking you to plug in 1 for x, what happens if I ask you to plug in 4 for x? If I ask you to plug in 4 for x, I go to the original, right? I'm going to go to the original first, to this one, and I'm going to plug in 4 for x. So I get 4 minus 4 over 4 squared minus 3x. Sorry, 3 times 4 minus 4. I get 0 on the top, no big deal. I get 16 minus 12 minus 4. I get 0 over 0. Uh-oh.
Sorry. Whoa.
This is a dagger. I can never have
Sorry, Dean. It's okay.
0 in a denominator. Division by 0 is undefined. Always, everywhere, no matter what. Division by 0 is undefined. So, I am going to say to this original problem, from the beginning, x is not allowed to be 4. I knew that from the very beginning, even though I canceled out the x minus 4. Remember, these two things, we write an equal sign, but they really are equivalent expressions. They generate the same answer, except when x is equal to 4. Because notice when I plug x equals to 4 in here, I think everything's fine. I get 1/5. But that's a lie. That is a lie, right? You can't use 4. So you need to tell when you are simplifying, you need to say that when I canceled and simplified out the expression, this new expression is equivalent to the old one, or the original, I should say, except when x is equal to 4. Okay? Now, if you are what's in red here is the fine print, and in reality, on any previous problems in previous math classes, when you have been asked to simplify an expression like this, all you needed to do was simplify. Nobody asked you for the bad x's when you were, the x that blew it up into 0 over 0. But now you need to think about it. Okay? Now, for what we're going to do with limits, it's important for you to understand when you had an x that blew up the original function, and division by 0 blows it up, right? That's your bad thing. So, another thing that I want to highlight to you, it's not going to become important until Unit 4, is this whole idea of not only did I get a division by 0, but I also got 0 in the numerator. It's going to become important later that you recognize when a fraction is 0 over 0 or any other number over 0. Okay, that's just a little foreshadowing. You don't have to worry about that right now. I don't think I'm freaking finally done with the first problem. Let's go on to number 2. Okay, so number 2, notice something to notice. This was a x to the first. This was an x to the first over an x squared. So notice I only had one factor that was available to cancel out because the numerator only had one factor, whereas the denominator had 2. But in this case, the numerator is going to have 2 factors, and so is the denominator. X squared minus 16 is one of those special quadratics that you should have done 500 of in Algebra 1. If you do not immediately recognize the difference of 2 perfect squares on the list of things for you to worry about for calculus is recognizing the difference of 2 perfect squares. Okay? So maybe up here I will make sure to highlight you need to be able to factor quadratics quickly and easily, not just, that's something that needs to be fast. You need to be able to recognize the difference of 2 perfect squares when you are factoring quadratics. So x squared minus 16 is x minus 4 times x plus 4. There's only 2 terms, and it was the fact that I have a minus and a plus here that made those 2 cancel out. The numerator is also going to have 2, because of the 2. That's not a coincidence, right? Going to have 2 factors. But again, since the leading coefficient here is just 1, I just need to think about what factors of 32 will add up to negative 4. So hopefully fairly quickly you realize that is an 8 and a 4. And And in order to get a negative 4, a negative 8, and a positive 4 gives me negative 4. And again, I have multiplication in between the two factors. And x plus 4 divided by x plus 4 is a 1. And that leaves me with x minus 8 over x minus 4. Don't you dare cancel those x's, right? You don't have multiplication here. So this is the equivalent expression, but what did I just say with number 1? You have to remember. This equivalent expression can be used instead of the original, except for what number? Right, here's the original. When the blue box and the red box will give you the same answers, except when x is what? Like pause, fine print, that's a comma. X cannot equal, look at the canceled out factor. Right? What happens if you put a negative 4 into the original? If you put a negative 4 into the original, you get a 0 here, times who cares is still 0. And then you have, right, blows up. So the blue box is equivalent to the red box for every number except for negative 4. Now, side note, this red box can't be used whenever x is positive 4 either, but neither can the blue box, right? Here, you only have to take care of saying this statement here is just to take care of the fact that, hey, the red box is simpler, but it covered up, kind of like when you put makeup on a zit, right? It covered up the fact that you can't use negative 4, so that's why you have to state it. Okay. All right, let's move on to C. Now, hopefully here you can see another pattern, right? That is the difference of two perfect squares. This time, it's x minus 5 times x plus 5. Now, this is such a bummer. I have 5 minus x on top. In a room, it is a factor. There is a 1 times 1. No factors match, but here's something that's going to come up a lot when we're doing limits. Do you see that factor and this factor? They are so tantalizingly close, but they are not the same. You cannot cancel them. However, watch this handy dandy trick. I'm going to do a rewrite that nobody asked me to do. So I have this blue 1 out there. So I'll make it blue again. Or cayenne, whatever that color is. Cyan, how do you say that? I have a 1, and then I have a room. But you know what I want in that room? I want x minus 5. You can't just freaking go and change 5 minus x to x minus 5. But check this out. What if I suck a negative? What if I take a negative out of here, right? If you factor a negative 1 out of this room, right? Take a negative out of a positive, well, you're going to be left with a negative. Take a negative out of a negative, you're going to be left with a positive. So notice that if you doubt me, distribute this back. What is negative 1 times x? Isn't that negative x? And what is negative 1 times negative 5? Isn't that positive 5? And if I've lost you, let me go over into this workspace. My claim is that 5 minus x is the same as take the negative out front, turn the x positive, and the 5 negative. Check me out. Check to see if I'm right. Plug in, I don't know, 2. What if x is equal to 2? Is 5 minus 2 the same as negative 2 minus 5? 5 minus 2 is 3. 2 minus 5 is negative 3. But negative 3 is 3. Go ahead and try it with any other number. It's going to work. Now, the whole reason I did that was because I was trying to match one of the factors in the denominator. Boom, boom. I now have negative 1 over x plus 5 is the equivalent expression to the original. So I succeeded in getting a simpler version of the original. Here's the original. The red box is the simplified version, which means I will get the same answer no matter which version I use, blue box or red box, but you have to come clean and say, by the way, fine print, x can't be what? Right, go back and see who did I cancel out. X minus 5. What makes this 0? And again, just to be clear, I should already know the red box. Neither the red nor the blue box can you use negative 5, but the red box looks like you should be able to use 5. But because in the original you could not use negative 5, could not use 5, right? Because again, let's plug in 5 to the original. What happens? I get 5 minus 5 over 5 squared minus 25, which is again 0 over 0. That's that special blow up. Okay. All right, let's go on. I'm still with simplifying, but I have some special directions with simplifying. I can't just simplify and however I want, or, without any conditions. This one is leaving me conditions to say that I need to have positive exponents where applicable. That just means some of the problems that we give you might not have any exponents, so you don't have to worry about it. Now, again, the reason for this is for multiple choice, of which 50% of the AP exam is multiple choice. And when you have an answer, you do all this calculus, you get the right answer, and you look over at choices A, B, C, D, and E, and your answer isn't there. And that's because AP likes to use positive exponents. So I'm actually not going to do the first one first. I'm going to work with the second one. Right? And the reason I'm not going to work with this one first is because this is actually the most important one for calculus. Because it applies again to limits, as well as something called the definition
This looks right?
of
101.
derivative.
Yes.
Okay.
You can't
So
go up
both
further.
of those
but
topics in
14
calculus
minutes longer.
this problem relates to.
Yes.
This is more just for like
Yes, this is right.
any problem that you might do, get a final answer for, and this answer isn't there. So pretend that you've done a bunch of calculus and you've gotten to this response, and this answer isn't there. They never will have fractions within fractions. So the first thing we're going to focus on is the fact that division is actually a lie. There's no such thing as division, really. Division actually is multiplication of the reciprocal. So I want you first to change this problem. Legally change a division into multiplication. So take 2 over x squared and change it into multiplication of not 10 over x to the 5th, but x to the 5th over 10. And now what happens? Hopefully you see that because I have multiplication, I have nothing but factors here. So 2 cancels with the 10 because that's 2 times 5, so the 2 divided by 2 cancels. And then remember, this is actually, I'm going to kind of write, this is actually 1, 2, 3, 4, 5, right? X is all multiplied together. And then I have 2 x's in the denominator, and I still have the 5 because I've already canceled out the 2's. X divided by x is 1, x divided by x is 1, and what am I left with? Good. Do I have positive exponents? Good. I'm done. X cubed over 5. Again, if you chose x is to be equal to 4, what do you get in the original? In the original, if x is equal to 4, you get 2 over 4 squared divided by 10 over 4 to the 5th. And that is 2 times 4 squared times 4 to the 5th over 10. And that is 2 times 4 cubed over, I'm sorry, canceling out the 2, right? 4 cubed over 5, which is 64 over 5. But look what I get right here if I used 4, right? 4 cubed over 5. Right? I didn't have to go through all this nonsense more than once. Again, I'm going to save that. I'm going to come back to that first problem, A. Notice right away I have a negative exponent in the problem. Don't like that situation. But let's break this up. Let's group things together. This is 12 over 18 times x to the negative 3 over x to the first y squared over y to the negative 1. Now, if you don't remember what a negative exponent means, a negative exponent means move the variable, change the sign on the variable. So what that means if I actually have here is instead of, since I'm not allowed to have negative exponents, this is really x to the 4th. And this is really y to the 1st. So I moved the variable, changed the sign. I moved the variable, whoops, x cubed, change the sign. Now over here, I have have a common 6, don't I? That's 6 times 3, sorry, 6 times 2, and that's 6 times 3. So the 6 divided by 6 is going to cancel out. So I am left with 2y cubed, right? Y cubed over 3 x to the 4th. Here, the reason we put this problem here was to have you remember that radicals are really exponents, right? If a square root, there's no number inside the little check mark there, it's a 2, and the exponent on x, if you don't see one, is a 1. The check always is the denominator. Okay, so what do I have here? Well, the 15 and the 5 reduces to 3, right? Do you remember what to do? So the last problem we didn't have any of the same variables, right? They were all together, but this time I have an x and an x in the numerator and the denominator. Right? That means you write the x here and you subtract 2 minus a half. So that's actually 3x to the 2 minus a half is 1.5. We rarely use the decimal approximation, decimals in calculus. So we write that as 3x to the 3 halves. Nobody told me, right? They wanted my answers with positive exponents, so I'm leaving that like this. I'm not going to turn that back into a radical. Okay. These ones hopefully are fairly easy for you, right? These ones really are algebra 1, 5. Since I'm multiplying here, 5 times 4 is 20. And this is, if you have c the base once, with multiplication in between, add the exponents. Here is the case where you only see the base once. I see 4 once. So write 4 down and multiply the exponents. And the exponent of 4 is 1, and 1 times 3 halves is 3 halves. And then you only see the base a once, so you write it down, and you multiply the 2 exponents, and 5/3 times 3 halves. The 3's will cancel out, and you've only got a 5 halves left. Now, you leave a and the 5 halves there, but in AP you're going to have to simplify an integer to a fractional exponent. So you have to put the check mark back. That's the square root of 4, all cubed, times a to the 5 halves, and the square root of 4 is 2, and 2 cubed is 8. Now again, I haven't forgotten that first problem, A, but I wanted to get here first. This is a complex fraction. You can't have a complex fraction. You've got to get this down to just one fraction. So the first thing I have to do is deal with the numerator. To subtract a fraction, I need a common denominator. So I'm going to multiply the first fraction by 1, and I'm going to get 2 over 4 minus 5 over 4 divided by 3 over 8. That's negative 3 over 4 divided by 3 over 8. And then I'm going to do what I've done before. Change the division into multiplication of the reciprocal. 3's cancel out. I end up with negative 8 over 4, which is negative 2. Now I want want you to think about that process, right? I just used elementary school fractions, subtracting fractions, get a common denominator, then change division into multiplication of the reciprocal. So I want you to think about what I'm going to do here, right? This is just, I don't have the complex fractions part, but I have to subtract fractions. How do I subtract fractions?
Close.
Right? So again, if you had something like 3/4 minus 1/5, how would you get a common denominator? Right? The common denominator would be 4 times 5 because neither 4 nor 5 have anything in common. So what does x plus h, the factor, have in common with x, the factor? I know they both have an x, but as a factor, they've got nothing in common. So what would I do to this problem? If my common denominator was a 20, or 5 times 4, wouldn't I multiply this times 5 over 5, and this times 4 over 4, right? Well, that's exactly what I'm going to do here. My common denominator is x plus h times x. Think of this as 5 and 4. 5 and 4, right? And I multiply them together and get 20. I'm not actually going to multiply them, right? Couldn't I have just done this? Right? 5 times 4 is 20. I don't have to multiply it out. Now, what's my numerator look like? Well, what did I do over here? I need to multiply by what's missing. X over x. X plus h over x plus h. The denominators are x plus h times x, and my numerator is x minus x plus h. That's exactly what I did over here. This, I would have 15 minus 4. And that would be 11 over 5 times 4, or 20, right? What is this going to be? This is careful. This is, I'll write it over here. X minus h. And what happens there? X minus x is actually 0, so you get negative h over x plus h times x. Again, I can't tell you how many times you are going to have to deal with expressions like this in limits, in our limit unit, and then definitely in our definition of derivative unit. Right, I was totally stressing since my computer was telling me I had a low battery, and I'm not with my charger right now, so I got through. Woot! Alright, so that's the end of the first video. So I'll have some supplementary practice for you, but you should keep a note, right? We had 2 things on our list already, right? Factoring quadratics, difference of 2 perfect squares, right? Those were already on your list. Exponent rules. Right? Converting radicals into exponents. And then just simplifying fractions from elementary school. Okay. All right, so I will take questions on this on Wednesday in our Wednesday lesson, and also have a few more practice problems for you on this page. Take care, and I'll see you then.